Hello friends. Friends, today we will discuss the concept of Poisson's and Laplace equations. In physical electrostatic problems, conductors are involved. In physical electrostatic problems, conductors are basically involved. And charge distribution is not known in advance. This problem of obtaining charge configuration for conductor configuration and initial conditions can be solved by Poisson's and Laplace equation. This problem of obtaining charge distribution, charge configuration for conductor configuration and initial conditions can be solved by Poisson's and Laplace equation. So let us discuss these equations one by one. First of all, we will discuss Poisson equations. Poisson's equation. Okay. As intensity of electric field E is related with the potential by this relation I have discussed in my one of the previous lectures, E is equals to minus del V, that is E is equals to gradient of V, where del is equals to I cap curly by curly x or d by dx plus j cap d by dy plus k cap d by dz is known as del operator. Okay, now for a continuous distribution of charges of volume charge density rho, the differential form of Gauss law is given by del dot E equals to rho by epsilon naught. Del dot E is equals to rho by epsilon naught. This is one of the Maxwell equation, basically known as Maxwell's first equation, already discussed in one of my previous lectures. So this is our equation number 2. Now if we put the value of E in equation number 2, that is basically you have to put equation 1, put equation number 1 in equation number 2. So equation number 2 will become del dot minus del V equals to rho by epsilon naught, or del dot del V equals to minus rho by epsilon naught. Now this is equation number 3. Now what should be del dot del? This is I cap d by dx plus j cap d by dy plus k cap d by dz dot I cap d by dx plus j cap d by dy plus k cap d by dz. So if you will do the dot product, what you will get? D square by dx square plus d square by dy square plus d square by dz square. Okay, this is del dot del. And what is basically this? This is basically del square. This is basically del square. Now put this del dot del equals to del square in equation number 3. So equation number 3 will become del square V is equals to minus rho by epsilon naught, minus rho by epsilon naught. Okay, this is our equation number 4. This equation number 4 is known as Poisson equation. Poisson equation in MK system. It relates the charge density. It relates the charge density to the second derivative of the potential V. It relates the charge density with the second derivative of potential V. That is basically, if we know the charge configuration, we can find out the potential. We can find out the potential by using this relation. In CGS system, this is basically equals to del square V is equals to minus 4 pi rho in CGS system. So equation 4 or equation 5, these are known as the Poisson equation. Okay. Now second is Laplace equation. Laplace equation. Laplace Laplace equation. Now in regions where there is no charge or in charge free regions where volume charge density is rho, that is rho equals to 0, that is charge free region, charge free regions, and rho is equals to 0. Now if we put the value of rho is equals to 0 in equation number 4, basically in the max in the Poisson equation, then del square V is equals to 0. So here this is known as Laplace equation. Laplace equation is basically for the charge free regions, and where there are charges exist, then the relation is known as the Poisson equation. Now Laplace equation in one dimensional form is given by del square V is equals to d square V by dx square equals to 0, and its solution is V is equals to mx plus a. It's a straight line. In two-dimensional form, it is given by del square V is equals to d square V by dx square plus d square V by dy square equals to 0, and its solution is V xy is equals to 1 by 2 pi r VDL. This is basically a circle, where r is the radius of circle about a point xy. Similarly, in three-dimensional case, this is equals to d square V by dx square plus d square V by dy square plus d square V by dz square equals to 0. So the value of V at any point P, is the average value of V over a spherical surface of radius r centered at P, and it is given by Vp. For the three-dimensional case, solution is 1 by 4 pi r square VDS. Okay, so Laplace equation is used to find potential in a charge-free space. Laplace equation is applied to such cases where all charges are distributed on the surfaces of the conducting bodies, or to the bodies where volume charge density is 0. Okay, like suppose this is a surface and the charges resides only at the surfaces, Inside it is charge free region, volume charge density is 0, but the Poisson equation is applied where the charge density exists. So dear friends, these are the two Poisson and Laplace equation. I hope so you have understood. If there is any doubt, please discuss in the comment section. Thank you. Thanks a lot.